Here you see us launching multiple rovers. The rover count has been set to 3 rovers. You can see in the top left terminal that the ROS service has been started. The below terminal is used for all the ROS nodes that are initiated. Here you can see us listing all the topics such that you can see that 3 rovers have been spawned. Now we are going to have a look at all those rovers that have been spawned. So here you can see our first 2 rovers. But the third rover has already been programmed to move away, and that's why it is away from the other 2 rovers.
So we also did some stress testing of the rover spawning. Without recording, we were able to launch 100 rovers simultaneously, and these all functioned correctly. However, while recording, the performance of the system was way worse. So we were able to use 50 rovers. As you can see in the terminal, all the topics of the 50 rovers have been created. Now we're going to look them up in the simulation. As you can see, 50 rovers have been spawned. Some of them are moving for a bit because each rover has its individual control algorithm. You can also see the green lines that indicate that they can communicate, and this will be explained later on in the video. This week we also improved our perception system. The blue rays still represent the perception system of the rover, and each dot now represents what the rover actually sees. We changed our top view camera to an orthographic camera. This allows us to have a 2D view from above for easier debugging.
We have also implemented support for configurable variables from the ROS side. On the left side of the screen, you can see all the variables that we have instantiated by now. On the right hand side, you can see that Unity will load in these variables. We basically now have one file for both configurations, as they're used by both Unity and by ROS. We have also added a rotate action topic. From this topic, you can rotate the rover. You basically give in the degrees that you want the rover to turn. Negative degrees implicate to rotate it to the left-hand side, while positive implicate that you want to rotate to the right-hand side. This week, we have also implemented our first version of the single-rover behavioral algorithm. The rover basically is looking for a place that it can go next without hitting an obstacle. As this is our first version of the behavioral algorithm, there will still be a lot of improvements made. But our rover is able to navigate through the little obstacle maze that we made without any problems. Here you can see the behavioral algorithm from another perspective. The route the rover takes is basically the same as seen in the previous section. This week we've also worked on properties of communication. The circle that you see around the rover is the communication radius, which is configurable. If another rover is within this circle, it will connect them by a yellow line. If any objects obstruct this ray, then communication is lost and the yellow line disappears. This week we've also worked on the communication backend. Every rover has their own topics, inbox and outbox, which messages can be sent to. Messages consist out of a message and a target rover. If a rover receives such a message in its outbox, it will try to send the message to the target rover. As you can see, our message system also supports embedded messages, such that messages can be forwarded to different rovers. We have also made a very large message to stress test our communication system. In real time, this is actually way faster than that you see here, but because the echoes of the terminals can't keep up with all the messages, it looks like it's way slower than it actually is. In the end, you will see that the last final message that is embedded has been sent.